UDS Tutorial Part 3. Control ECU Outputs with Vehicle Spy. UDS IOControl and Diagnostic Modes. Welcome back. In our last video, we saw that we could read the speedometer's position, but we couldn't change it using the simple snapshot view. That's because some tasks require more control. Today, we're going to dive into the Diagnostics view to successfully take control of that speedometer needle. To start, let's go back to the Snapshot tab and click the Test or Present button to turn off the automatic message from the screen. The reason our first attempt failed is that for complex tasks, like controlling an output, we first need to put the ECU into a special state called Extended Diagnostic Mode. Think of it like putting your phone into a special setup mode before you can change important settings. We also have to send a constant test or present message to the ECU to let it know we're still connected and working. First, make sure you are online with your Intrepid hardware. Now, let's go to the place where we can build these special commands: Spy Networks, and then Diagnostics. For this task, we need to create a few of our own commands. Think of it as building a custom remote control with a few special buttons. First, let's make our Enter Service Mode button. Click the plus button to create a new job. Choose ISO 14229 and then Diagnostic Session Control. In the setup screen, we will choose Extended for the diagnostic session. Let's link this job to our 710 Speedo ECU by clicking the ECU icon, and then name this job Diagnostic Mode. It's also a good practice to have a Go Back to Normal button. Let's create another Diagnostic Session Control job. This time, choose Default Session. We'll link it to the Speedo ECU again and name this one Default Mode. Next, we need the button that will actually move the needle. Create a new job, this time choosing Input-Output Control by Identifier. We'll link it to the Speedo ECU. For the data identifier, select ID Speedo Pointer. And for the control parameter, choose Short-Term Adjustment. We will name this job Adjust Speedo. Finally, how can we be sure we're in the right mode before we try to make a change? Let's build a quick status check button. Create a job using Read Data by Identifier. Link it to the Speedo ECU and add the ID cluster diagnostic state to the list of selected identifiers. Let's name this Read Data Identifier. Okay, we've built all the buttons for our remote control. Now it's time to press them in the correct order. First, we need to keep the line of communication open. In the job list, find the pre-made Test or Present job and check the box next to Test or Present to start it running. This message automatically resends every 2 seconds, which is important because the ECU will time out and exit diagnostic mode after 5 seconds if it doesn't hear from us. Second, with Test or Present running, we can now enter our special mode. Find your Diagnostic Session Control job and check next to the box Diagnostic Mode to run it. You should get a positive response, but let's be certain. Run your Read Data Identifier job. The result should confirm that the diagnostic state is now Extended Diagnostic. Now we are ready. Select the Adjust Speedo job, but don't click the checkbox yet. Go to the Setup tab for this job. In the signal list at the bottom, enter 20 into the value field. Now, click the Launch button at the top. To see if it worked, you can check the first instance of Vehicle Spy that is running the car simulator on our NeoViRed 2. On it, you'll see the speedometer graphic, and the needle should be pointing right at 20. Success! We've learned that for advanced diagnostics, the sequence of our commands is critical. But what happens when a part is so important that just putting the ECU in a special mode isn't enough? That's where security comes in. You can read about security in our documentation. Thank you for watching. Reach out to us if you have any questions, and see more of our tutorials when you subscribe.